Namaskaram. Welcome to the course Basics of Electronics. In this video, we will be looking into solid-state relays and their application in electronic industry. This entire video is divided into 5 important parts. First one is what are solid-state relays and their working principle. Second one is types of solid-state relays and their current rating. Third one is selection guide for SSRs with their circuit diagrams. Fourth one is applications of solid-state relays in real time. Last but not the least, we'll conclude this video with the advantages and disadvantages of SSRs in industry. So let's start. What are solid-state relays and how does they work? Solid-state relays are the electronic switching devices which are used for switching a high-level AC or DC loads with the help of very minimal DC voltage at the input side. It consists of a LED, photodetector and or a triac with a couple of resistors inside that particular component. When a low-level DC signal which is ranging from 3 volt to 32 volt is applied to the input LED, then a LED will illuminate the light inside. This package is so tiny which is not visible to the external people. However, this light falls on the photodetector or a triac which will trigger the path connection between the emitter and collector at the output side, which enables the continuity at the output load so that it can switch the high level DC or AC signal at the output level. This is how simple the SSRs work in real time. Unlike the electromagnetic relays makes a noise when they are switching from one state to another state, these SSRs doesn't make noise because of optoelectronic system inside them. Types of solid-state relays in electronic industry. There are numerous applications or numerous requirements in the switching industry of power electronics. Based on the requirement, there are a variety of applications and variety of categories available for solid-state relays. However, based on the input-output, output power, switching signal method or isolation power method, we can categorize these SSRs in various categories. So let's discuss them one by one. First one is based on the input-output, SSRs are categorized into AC to DC SSRs or DC to AC SSRs. Which means when you apply a AC voltage at the load level, internally these SSRs are having a rectifier to convert that AC signal into a DC signal. At the same time, they also have an inverter which will convert a DC signal into AC signal for the sake of specific application. Second one is based on the power signal. At the time of switching, which type of signal it is switching constantly. Say for example, if it is a DC SSR, then it is only capable of switching a DC voltage at the load level. If it is a AC SSR, then it is only capable of switching a AC signal at the load level. Third one is based on the isolation method. These SSRs are categorized into 4 categories. First one is photocoupled, second one is transformer isolated, third one is reed switching or reed coupled, or the fourth one is a hybrid one. As name indicates, the first one photocoupled is nothing but using a LED to trigger the load side circuit, and transformer coupled or transformer isolated is all about using a high frequency transformer, and third one is all about with respect to reed switches. Hybrid one is a mixture of couple of other options. Fourth one is based on the switching method. These SSRs are categorized into 2 categories. One is normally open, another one is normally closed. It is as straightforward as with respect to electromechanical relays. Fifth one is based on the mounting method. These SSRs are categorized into PCB mount, panel mount, bracket mount and various custom mount application as per the requirement. Selection guide for SSRs and their circuit diagram. There are several factors and important notes to read and understand before selecting a SSR like switching devices for your application. However, I'm going to give you 7 important matters or the factors to cross-verify while you are selecting a simple SSR for your application. First one is based on the application, select the best fit SSR for your requirement. Say for example, if you are dealing with the power electronics, understand the power rating, understand the maximum area of coverage and understand how much load you want to switch. Based on that, select the specific SSR for that particular requirement. Second one is based on the form factor and mounting methodology, select a best fit SSR for you. If you are designing a compact solution for switching a AC load or a DC load, make sure that you use a PCB mount SSR, or at least try to understand what kind of a form factor to be used for designing your application. Third one is based on the poles and throws. If you are using a SSR for switching a multiple signal at the same time, then obviously you have to consider a multi-pole and multi-throw system, wherein you can either select a single pole, single throw SSR, or you can even select a dual pole, dual throw SSR as per your need. Fourth one is based on the input and output load level. If you are dealing with a high power DC or high power AC signal, then make sure that with the factor of safety, you select a best SSR for your requirement. If you select a very low level or low voltage capacity SSR at the load level switching, then it may damage the entire circuit. Though it is having a galvanic isolation in between, it is possible that it may travel the distance of one circuit to another circuit and damage the entire electronics in a fraction of a second. Fifth one is based on the industry standards and the certification level that you want to apply for your product development. Select those SSRs which are having a IEC certification or CE certification or any kind of a certification which are possible and required for your design industry. Or maybe for a large scale production, try to understand where you are exporting your product and based on that, select the specific SSR as per the requirement. Sixth one is based on the load current, select a specific SSR. If you are switching a load current of 10 ampere, then at least understand the inrush current and the peak current and select the specific SSR for that. For example, if you are switching a 10 ampere of a load, then try to understand what is the peak current of the entire circuit. Say maybe a 30% of factor of safety, which is going to be a 13 ampere, and select a SSR which is greater than 13 ampere. Say a 15 ampere of current rating at the load level. Seventh one is a frequency of switching. When you are selecting a SSR, make sure that that SSR is capable of a frequency of switching at which you are expecting it to be used. If in case you are using a SSR for a small scale of switching or maybe a permanent switching or one state to another state with not frequent switching, then it is not a matter of concern. But if you are using it for very high speed application or high switching application, then make sure your SSR is capable of operating at that particular frequency at which you are expecting it to be switched. So these are the 7 important factors to consider for selecting a basic SSR. There are hundreds of other reasons or other parameters to verify before selecting a SSR for a large scale production. Applications of SSRs in real time. SSRs are used in most of the applications in industry. Because of various features and advantages, SSRs are very widely found in industrial application more than electromagnetic relays. Let us consider a couple of applications with certain examples. First one is power supplies or switching power supplies. In case of electromagnetic interference while switching from one level to another level in the industrial machineries, SSR plays a vital role because EM relays are not best fit for them. In case of those power supplies switching from one high level voltage to low level or low level voltage to high level, these SSR plays a vital role. That's why SSRs are widely used in switching power supplies in industrial equipments. Second one is industrial conveyor belt. We know that conveyor belts are widely used in most of the industries which requires a transportation of material from one place to another place within that industry. On that time, when we are using a conveyor belt for to and fro motion or one point to another point and another point to the same point back, then SSR plays a vital role and very easy to operate them with a low level of DC voltage. That's why SSRs are used in conveyor belt system. Third important application is high temperature and low noise application. As I already mentioned, they use a up-to-coupled method for transmitting a signal from low level to high level or switching a signal at the load level with a low level of DC voltage at the input side. Because of no noise and also a high temperature capacity, these SSRs are used in various industrial applications, especially in thermal industries. Last but not the least, fourth one is PLC control system and industrial automation. In case of industrial automation where the low noise application is required to be implemented or a high temperature requirement is there, then SSR plays a vital role. We all know that PLC control system uses the EM relays most of the time. But in specific industry with a specific application, solid state relays are also used for an industrial application. Let us conclude this video with the advantages and disadvantages of SSRs in industry. First one, advantages of SSRs. There are hundreds of advantages with respect to SSRs when it compared with the EM relays. First one is no switching noise at the load level. Whenever you connect a normal electromagnetic relay, there is a sound as a tuck kind of a sound at the load level when it is switching from one state to another state. Whereas in solid state relays, there is no such noise because of semiconductor circuit inside, which makes it possible without noise. Second advantage is no electromagnetic interference with the nearby devices. When you are designing a solid state relay based circuit with the antennas or any wireless devices, then there is no worries to think about electromagnetic interference with the nearby devices. Third one is these SSRs are more rugged and durable in harsh environment as compared to the normal electromagnetic relays. Fourth advantage is these SSRs are suitable for AC and DC applications. As I already mentioned, they also equipped with the inverter or the rectifier or a certain converters inside, which makes them very suitable for inbuilt conversion of one signal to another signal, which makes them very useful for AC application as well as for DC application. Now let's talk about the couple of disadvantages of SSRs. Among them, first one is these SSRs are very expensive. As they come up with a bunch of features, these are very expensive compared to electromagnetic relays. Second disadvantage is there is a power loss at the load level even though load is not at the switched state. Say for example, if you connected any load at the output side, even though SSR is not activated, there will be a leakage current which flows through the entire circuit due to electronic and a semiconductor circuit inside. Third disadvantage is these SSRs will generate a heat to dissipate the power inside them, because when they are switched on, they are having a continuous transaction or continuous current flowing through the input circuit as well as the output circuit, and they are semiconductor devices inside. They will generate a heat which is nothing but a dissipation of energy. Fourth disadvantage is these SSRs are very sensitive to the spike of voltage at the input side. By mistake, if any spike or impulse comes at the input side, these SSRs will switch for a short period of time, and that may damage the load or maybe create any other disadvantages in the entire circuit. Alright, with all this information, now you are clear about what are solid state relays and their application in electronic industry. See you again in the upcoming tutorial. Until then, happy learning. Namaskaram.